Welcome to the series. This is where we learn how to build AI agents with the latest large language models like OpenAI GPT-4o, Anthropic's Claude, etc., and Langchain, LangGraph, LangSmith, and Python. This is the 7th video of the series. In this video, we will build Reflection Agent Orchestration. This is an architecture where multiple agents are involved with tools like Tavily web search, etc., and includes tool-based reflection agent loops. Here we will take the following steps. Step 1, we will go over the Reflection architecture with a diagram. Step 2, we prep the agent state and tooling. Step 3, we implement the nodes or agents, namely the planner, the plan researcher with tools, the essay writer or the generate node, the essay reviser or the reflection agent with tools. Step 4, we build and visualize the graph using LangGraph. Step 5, we add memory to the graph. Lastly, we run the graph and analyze the result on LangSmith. Now let's get started. All right, so this is what we're going to be building in this session. Reflection Agent Orchestration. This is going to be our example. User comes in with the topic of an essay as a task, gives it to the planner agent, and this agent has all the instruction to plan out a nice little report type essay, and this guy then pass it along to the plan researcher, and these two agents are connected via normal edge, which is the linear edge. This plan researcher now has the plan and the task both, and this guy also equipped with Tavily Search Tool. So he goes to the web, researches it, gets the data, and augments the task and the plan with some more context about the essay. And then he sends it to the generate agent, which is the actual essay writer. And these two guys are also connected via normal edge, which is just plain old linear edge, no condition attached. But now that the essay writer has all it needs, it goes ahead and generates the first draft of the essay and then sends it to the reflection agent. If you've been following this series, you know already that what a reflection agent orchestration looks like. This is exactly what that is. Only difference is this time our reflection agent has tools, specifically the Tavily Search Tool. So this guy also takes it in, analyzes it, goes online, researches it, comes back with a revised version, and then sends it back to the generate agent or essay writer. And this would be the reflection response or the revised edition, right? And this goes on and on in a loop, just like we saw before in the reflection agent structure. And also, just like before, these two guys, the essay writer and the reviser, are connected using conditional edge. Normally, how many times this will be looped, how many revisions there will be available, it will depend on this reflection agent. But we cannot let everything dependent on AI itself, right? So that's why we create a conditional edge where we throw in a max revision number. I mean, highest number of loops this can go through, and we maintain a revision number in the state of the LangGraph. Every time it circles in, we just take that revision number and compare with the max revision. So let's say if I set it to 5, then it will not go over 5-time looping, right? But that also doesn't necessarily mean it will always go up to 5 times. I mean, it always depended on this reflection agent person. So what we can tell about this reflection agent orchestration is that the reflection loop is still present. Only difference is it is equipped with tooling, and on top of that we added other agents here like the planner and the plan researcher, who are also equipped with search tool or something that's necessary. So anyway, at this point, whenever it reaches the max revision, or this guy, the reflection agent, decides that this product is ready, then either this guy will send a end signal, or this conditional edge will send an end signal to our generate agent or essay writer, and that will let him know that it is time to get out of the loop and send the final essay draft to the user. And that's about it. Now let's go build this thing. All right, so let's get started here. Let's check out the installations. These are the libraries. The new one coming in here compared to the previous one is Tavily Python. This is the one we will create the Tavily Search Tool with. Other than that, you can see our LangChain version is 0.3.9 and LangGraph would be 0.2.53. Pretty much the latest and the greatest. And then we just load up our environment variables. As you can see, the OpenAI API key here, Tavily key here, and the rest of the four are the setup for the LangSmith tracing, right? So with that, let's go to the testing phase. Something that I do just to check out the LangSmith stuff. Let's say if I click here and a URL does show up, that kind of tells us that we are connected to LangSmith properly. And then this is the one to set out, test our model and also go back and check with LangSmith if it is being registered. So let's run it, a quick one. All right, we see the result. Now let's go back. Boom, there you go. So we have our Reflection Agent Orchestration project, and the one we just clicked, all the details are here. We are good to go. All right, so this is how our Reflection Agent Orchestration is organized. Step one, we're going to do some preparation, prep our tools and states, etc. Step number two, we're going to implement the nodes or the agents, create our Python functions. Step number three, we're going to build the graph and visualize the graph. Step number four, we're going to add memory with SQLite Saver library. And then step number five, we're going to see the graph in action. We're going to run the graph and analyze the results in LangSmith. So let's get started. All right. Okay, so step number one, we first load up our libraries. These are our libraries, and we make the model right here. Let's run that. And then define our agent state. So right here, we're going to bring in typedict, list, and annotated from the Python typing library and construct our agent state. As you can see here, we're going to have task, plan, draft, critique, all strings. The content would be the returns, the AI responses. So it's going to be a list of strings or an array of strings if you are coming from JavaScript. Revision number, integer, max revision integer, right? So this is the structure we're going to follow for our data all throughout the graph. Now let's set up some more data type and tooling. So here we are bringing in base model from Pydantic and the Tavily client from Tavily. So right here we are creating our query structure, and this is going to have the list of query strings. This is going to be used by our researcher agent, where it's going to get some content and create some search queries for the Tavily Search Tool, and then it's going to be passed to our Tavily tool that you can see right here. This is going to be used as our Tavily tool. So all that being done, let's move to the next step. This is the implementing the nodes. Okay, so first let's go to the diagram a little bit. As you can see here, we need the planner and the plan researcher, right? These are the first two guys we create. So let's see what the planning node looks like, or planner agent. The most important factor here is this plan prompt. This is the system prompt that makes the guy who he is. You are an expert writer tasked with writing high-level outlines of an essay, blah, 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 blah. So this is basically creating the outline of the essay. That's what all this guy is going to do. So now we are creating the node, the plan node, and as you saw before, the state is being passed, and the data structure would be agent state that we just built. And then the message structure, the system message, we're going to send this plan prompt, and from the human message, we're going to send the task, which is basically the topic, as you see here. So this topic is going to be passed to the planner, and this guy will invoke the model using this message. and we're gonna get a plan back, and we're gonna add that to our state like this. So next we go to our research planner, or plan researcher. Once again, the most important factor is this system prompt. You are a researcher charged with providing information that can be used when writing the following blah blah blah. Generate a list of search queries that will gather the relevant information. Only generate 3 queries max. So we're also limiting it with a 3 query maximum. And right here, we're gonna create the research plan node or the agent. As usual, we're gonna sending the state as agent state. And here, we're gonna invoke our model.with structured output. And this is where our Pydantic structured output library is gonna be invoked. So with that, we're gonna send the queries here and invoke it. And the system message, research plan prompt, this guy right here, and human message would be the task, which is the research topic. And whatever we get back, we just we create a content with get state and content, which is currently an empty query, but then what the research result that we're going to get in from the response from this Tavily.search and query and the maximum 2. We're going to go ahead and loop through it and append it to the content, this guy right here, and then return the content, which is one of our data items in our agent state. So this guy is returning the research content and the search queries. Now let's go to our generate, the main guy who's going to be responsible for writing the essay. So this guy now has this prompt. You are an essay assistant tasked with writing excellent 5-paragraph essays. Generate the best essay possible, blah, 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 blah. And this is the most important part. If the user provides critique, respond with a revised version of your previous attempt, utilizing all the information below as needed. And here we are passing the content as a prompt variable. And this is basically nothing but what this guy sent after getting the answers from Tavily Search. So that content is going to be passed along here. And with that prompt, we're going to go ahead and generate our generation node. Initially, we just take all the content and make them into one string and call it content. And then the user message, we're going to go ahead and add the task. And we're going to say, here's my plan. And then drop the plan in there. And plan, which we got from the earlier from the planner agent. As you can see, state plan and state task, these are all coming from this agent state data structure that we built at the beginning. So now we build our message. So it's going to be the writer prompt, which is this guy right here. This is what's going to shape up this agent's character. And then this is our prompt variable content that we just built right here. And then we're going to send the user message, this direction right here. So at this point, we're sending not only the research result, but also the name of the task and, or basically the topic of the essay and the plan that was generated by our plan generator. So let's go back to the structure a little bit. So this is what's happening. Planner did the plan, researcher augmented the plan with the extra data from the web search, and then task and the plan and the extra data was sent to the generate agent, who is the essay writer. Now he's going to generate his first content. So now let's go, and send it to the reflection agent. This is the reviser of the essay with tools, right? So now let's go back and see who that guy is. So this is the critique or reflection agent node that here you can see actually there are 2 agents, right? But in the diagram, I had them as 1. So this was the initial plan. But then while I was trying to create it or design it, turned out that putting all this into one agent was getting too messy. So I decided to break it down. So initially, this is just a simple reflection agent. You are a teacher grading an essay submission, generate critique and recommendation. See, all this information is already given to him, right? He's going to generate the critiques of the essay and provide an in-depth analysis of it. right? So that's exactly what it's going to do. And in the end, it's returning the critique, response.content, which we just got by invoking the model with this message. And as you can see, the reflection prompt is right here. So we got our critique, but now it's going to go ahead and pass it along to this critique researcher agent node. This guy is the research assistant. You are a researcher charged with providing information that will be used when making any requested revisions as an outline below. Generate a list of search queries that will gather any relevant information. Only generate 3 queries max. So these guys pretty much take the critique from this agent state, and his system message would be this critique, which actually shapes his character. And then human message he will receive is the critique, which we just got from this guy right here. And based on that, he's going to generate 3 queries max. Just like before, we have the content from the state, and then we loop through those 3 queries and send them each to Tavily Search and collect the response in this response variable, and then loop through those results and append them into the content, this content variable, which is augmenting this state variable, and then return that content back. So with this now, we finish all our agents. So let's go back to the structure again. So pretty much we broke this guy down into 2. One is creating the critique, the other one is doing the research, and the combination of that will become our reflection response, and then send back to the generate agent or the essay writer, and he will be generating a revised draft accordingly, send it back to the guy, and this will go on and on until we hit the max revision, right? So right now we have our planner agent, our plan researcher agent, the essay writer agent, the reflection agent, and the researcher agent, everything done. So now we are ready for the graph. Okay, so as we can see, the graph has 2 parts. First, we define the conditional edge. As mentioned before, in our agent state, we have the revision number and the max revisions. So as we loop through, when the revision number reaches the max revision, it goes to the end, and our generate agent will know to return the final draft to the user. Otherwise, it will return reflect, and the moment it returns reflect, the whole loop, the graph loop, the reflection loop will know to go through the full circle again. Otherwise, it will go to the end. So now let's define the graph. This is the big one. But it's a lot simpler looking than before when we created our reflect agent in the previous video, because I have to admit I wasn't organized like this. We were, while building the graph, we were also creating the nodes. So in here, it's much more cleaner. So now we already know all our agents. We're just going to add those nodes to the graph. Builder.add node planner. And by the way, we create the builder using state graph and send the agent state as an argument. And this is the one I was talking about last time, because in our reflection agent orchestration, we used message graph instead of state graph. But now state graph we are using because, as I mentioned before, this can hold all different types of data like integer, string, list, etc., etc. So it's much more versatile. So now we are implementing this one to create our builder, since we have all sorts of different type of data involved, right? So as you can see here, the planner, the generate node, the reflect node, the research plan, and research critique planner node all added. Now notice this does not have to follow an order. We don't care. When we are adding them to the graph, they are not talking to each other. No connection has been established just yet. Connection establishment happening right here, begins now with a set entry point. So here we are clearly saying planner is the beginning point. Let's go to the diagram once again. As we see here, planner begins the whole journey. So we are just setting it as an entry point, and immediately afterwards we are adding the conditional edge to the generate node, just like shown here. The conditional edge to the generate node, and we are calling that function should continue. And this function we defined a little bit above, and then we are giving it two outcomes. One is ending the graph or returning reflect. If it returns reflects, we go another cycle. If not, we end it right here. And this is where this function has our max iteration also. So after this conditional edge is done, now we just add our regular edges, like planner to the research planner to generate, reflect to research critique, and research critique to generate back again, right? Basically, these are the connections. The normal edge, and another normal edge. So our graph is now built. Okay, now comes adding memory to it so that it doesn't lose track of what it's doing. To add memory, we just get this Langchain checkpoint SQLite library from LangGraph. All right, so now that this is installed, so this is the structure we use to use this SQLite saver and memory saver to create our memory, and then add that memory to the graph using this function, builder.compile. Basically, we are taking this builder and compiling it. Let's do that. Okay, so our step 4 is also ready. Now let's go see our graph in action. So first we start by viewing the graph, and if you've been following this series, you're already very familiar with this structure using IPython and sending graph.getGraph.drawMarmadePNG to generate a PNG image of our structure. Now let's look at it in a full view. So this is what it looks like that we just built. Start, planner, research plan, generate, and that's the loop to the reflect, research critique, goes on and on until it reaches the max, and then end it. Done. So finally, we are ready to run our graph. So here we are just creating a thread, configurable thread ID equals 1. This is to keep track of the memory for the SQLite memory. And then the task, here I'm just saying reflection versus reflection agent. Give me an essay about comparing these two. This is basically the topic or the task. And then in the prompt task, max revision 2, and I'm intentionally keeping it light, fewer, because this is already going to take a while to run, so we're not going to go more than 2 here. And revision number 1, which is this is the starting point, right? So with this prompt, we take our graph and use .stream to invoke it with prompt and the thread. This is the memory tracker, and this is the prompt. And then we're just going to go ahead and print them out as they become available so that we can see them step by step. So let's go. And as you can see here, a lot is happening, right? So it's going to happen. It's going to take some time. As you can see already, planner is already done, creating outline. Oh, there you go. The research planner is also collected the information with Tavily Search. Now send back to the generate agent. And generate agent created a draft already. So now reflect, there you go. So our first critique has been generated, and critique has been researched using Tavily Search Tool, and once again send back to the generate or the essay writer. So this guy now generated another revised version, and that's it, because all we did was limited it to revision 2, so that's exactly what happened. So now that we know this, before we go to LangSmith, let's take a look at the final result. This is what the final draft should be looking like. There you go. The reflection agent versus blah 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 blah, and then understanding reflection agent, comparative analysis, conclusion, summary, etc., etc. So finally, we have our final draft in hand. This is the final product. Now let's go check the LangSmith and analyze a little bit more. All right, so we are back at our Reflection Agent Orchestration, and this was our first test, and this is the one what we just ran through. Okay, so this is the first guy, is the planner, and we can see that what the planner is doing. This is the system instruction, this is the task. Based on this task, he created a nice little outline, passed it to our research planner, and this guy went ahead and created this 3 URLs to research to use with the Tavily. And you can see here, because we actually asked for structured output, and this is the structured output it created using Pydantic tool parser. And then with the result and everything, it sent it to generate. And in here, this is the system instruction for the generate guy, and this is the search results. All those links that were used in this Tavily tool generated these results from the internet and send it to our generate agent. Based on that and the plan, our generate agent went ahead and created this rendered output. This is the first draft, right? And then if we look at our conditional edge, should continue, you see it's reflect. That means revision needs to be done. So send it to our reflect guy. So our reflection agent then receives the whole input, and then he renders an output with the recommendations, his critique. See, that's all the critique he offered, and then sends it over to our research critique guy, who gets that content and generates 3 more URLs to research based on that content. And also, once again, you see this is the structured output that we requested, so that we can easily use them in our Tavily search tool. Then, since our should continue answer was reflect, so it went back to the generate guy, and the generate now has these new details, extra details that our reflect research guy found. See all that extra text, and now it has more content and its suggestions. So based on that, the guy generates this final output. And if you now go to should continue, you will see that answer is end, because we limited this whole reflection loop only to max iteration. So that's it. Right after the first revision, second time it was done, and got this message end. And this final draft, what we just took a look at, was generated by our essay writer and sent back to the user. So with that, we finish our Reflection Agent Orchestration. Please like and subscribe, and until next time, thanks for watching.